All right, welcome back to the drive-thru, ladies and gentlemen, for a remix. We're going to include the audio on this one. Is the light on? Is it blue? It's not? I wonder if this thing's out of battery. Barely. I know, it stinks. All right, we're good. We're good. We are attempting to voice over. I would do an accent. I think that'd be great, but I don't really have any accents other than my twerking accent that I have. So we're just going to go straight forward, play this YouTube video, and I'm going to speak over it. This is the distance between a point and a line. So let's say we have a line and some point Q not on the line. Okay? How are we going to find the distance between... Come on, when's this video going to start playing? How are we going to... It's not paused. It's playing. Look. Here we go. Oh, that's right. I'm talking about sandwiches. All right, well, this is part 3 of 10.5. Hungry? Get yourself a sandwich. Maybe a salami roll-up with the new pickles that I just opened last night that are 2.5 years old from my basement. So if I get sick. All right. How do we define a line in 3 space? What do we need? We need a point on that line and a vector parallel to the line. So that's where we're going to start here. Okay? So we're trying to find the distance between Q and this line. Now, remember that the distance is defined to be the shortest path between 2 objects, so it's going to form a perpendicular. We will refer to this red line as D. Okay? Take any point on the line P and create a vector PQ. Think of the hypotenuse of this triangle as the magnitude of PQ. There will be some angle theta created. Now, before we get started, there's a couple things we have to remember. So, in Theorem 10.8 from Section 10.3, we did this gnarly, terrible proof to prove that U V sine of theta is equal to the magnitude of the cross product. That was that really ugly proof that kind of we got to, and then we just gave up on and said, hey, if you want to do this, go for it. And no one did it for understandable reasons. Okay? You have to understand that that's the premise of this entire equation. Are you there? Everybody okay with that? Okay, so look. Remember that to find this D, if we knew the angle, it'd be really easy. We'd just use trig. Right? So we would say sine of theta is equal to D over the magnitude of PQ. And we would just, get our Pythagorean or our SOHCAHTOA on and find D that way. So we're going to start this by just setting that up. So D is equal to, well, let's remember our trig. Sine of theta is equal to opposite. And I'm putting the magnitude on that, but it doesn't matter because D is already a magnitude. It just represents distance. So that's me just, kind of being confusing. Over the magnitude of PQ, which is the hypotenuse. So to solve that for D, we can get it is equal to the magnitude of PQ times the sine of theta. Is everybody okay with that? Now look, that starts to look like this. Okay? We're just missing a magnitude of U. And the whole goal here is how can we find the distance if we don't know what theta is? Because we're not going to know the angle between the vector and the line. We're just not going to know that. Well, if I multiply this side of magnitude of U, then I have to multiply this side by magnitude of U. Do you all understand what I just did there? And now look what I have over here. I've got this. Do you see that? So what can I substitute out this left side with? The magnitude of the cross product. So now I have succeeded in getting rid of that angle. Now I don't need theta anymore. So, next thing I'm going to do is I'm probably going to take this out and rewrite it as the magnitude of the cross product of U cross PQ. Don't do it. Don't skip the step. Don't do it! Uh-oh. Good. Good job. Rewrite the magnitude of U. Rewrite the magnitude of... There you go. So I've simply made a substitution here. Does everybody see that? And then in order to solve for D, the distance between the point and the line, what am I going to have to do last? Divide by the magnitude of U. And now we'll have our distance between a point and a line equation. And that is the magnitude of the cross product of which two vectors? Which two vectors? The direction vector and the vector defined by a point on the line and the point we're trying to find the distance from. We have to divide that whole thing by the magnitude of U, which is the direction vector for the line. This has been your R. Kelly remix. Boom!